Hello, Algebra 3. Today's lesson is on expanding logarithmic expressions. So our last one, 6.7, was on condensing logs. In this, we're going to go reverse using the same three properties, the product property, the quotient property, and the power property. And we're going to be expanding single logarithms into their longer counterparts. So let's get going with a few examples here. All right, our first example will be the log base 6 of x, y, z to the fourth. Okay, so we need to expand this one out using those three properties I had mentioned before. So let's look first here. This exponent 4 only goes to the z. Okay, it does not go to the y or the x. If it were outside the parentheses, then it would go to the y and the x, but in this case, it only goes to the z. So what we have here is log base 6 of x times y times z to the fourth. So the first property I'm going to use is I'm going to use the product property. Had that exponent of 4 been to this entire expression here, I would use the power property first. But it only belongs to the z, I'm going to break it into x times y times z to the fourth, and I'm going to use the product property first. Then I'm going to use the power property on that z. So if you remember the product property, when we're multiplying these together, we can basically add the logarithms of each. So I'm going to have log base 6 of the x plus log base 6 of y plus log base 6 of z to the fourth. So we're good here. We can't be expanding that anymore. We can't expand that anymore. Here is where we can use that power property. I'm going to take that exponent and I'm going to move it out front. So I'm going to end up with log base 6 of x plus log base 6 of y plus 4 times the log base 6 of z. And that would be our answer in the expansion of the original log here. So log base 6 of x plus log base 6 of y plus 4 times log base 6 of z. So let's look at another example here. All right, example 2, we're going to have log base 2 of, we're going to have y over z to the fifth, and we're going to raise that whole thing to the power of 2. So in this case, unlike we had in example 1, in this case our exponent of 2, that applies to everything going on in here because it's inside the parentheses, and this exponent belongs to the entire parentheses. So actually what I'm going to do first is I'm going to distribute, well, no, I'm going to go ahead and take that 2 outside. So let's go ahead and pull that out rather than distribute. So I'm going to put 2 times the log 2 of y over z to the fifth. So the next thing I'm going to do is I'm going to use that quotient rule to break up what I got going on here. So it's going to end up being 2 times the log base 2 of, I'll have my numerator first, and I'm going to subtract log base 2 of my denominator here, z to the fifth. If I wanted to go ahead and distribute this now, I could. I'd end up with 2 log base 2 of y minus 2 log base 2 of z to the fifth. So all I did was distribute that 2 through the parentheses here. So 2 times log base 2 of y, and then 2 times log base 2 of z to the fifth. So I'm almost done. There's one other thing I can do here. I can move this 5 out in front of this logarithm. I'm going to end up with 2 times 5 here. So I'm running out of room. Hopefully this comes through on the table. Okay, I'm going to 2 log 2 of y minus 2 times 5 is 10. 10 times log base 2 of z. And there's my answer on that one. 2 log base 2 of y minus 10 log base 2 of z. Give you one more example here before I send you off to the practice problems. to look at example 3, where I have the log. I'm going to take the log of the square root of 7x to the third. Now in this case, we have to go back and remember radicals. Okay, when we have a square root, that's the same as writing this to the 1/2 power. So hopefully you remember from Algebra 1 that when we were taking a square root of something, that is raising it to the 1/2 power. So fractional exponents end up with a radical sign. So now we can pull this 1/2 out front. We're going to end up with 1/2 times the log of 7x cubed. So now we can break this up inside here. So I'm going to with 1/2 times, now I have a multiplication here, so if you remember that product property, that means that we can add whatever we're multiplying in here. So we can end up with log of 7 plus the log of x cubed. And I've run out of space here, so I'm going to erase the top here and move this up front, or up top, I mean. So we'll bring this up top. We have 1/2 of log 7 plus log of x cubed. Okay, so that's everything from the bottom brought up top, and we will keep going. Don't forget, if you need to see some of the first half of that problem, you can rewind this. So now I can use my power property here and move that 3 out in front of that log. So that'll be plus 3 times log of x. I can go ahead and distribute this 1/2 through a set of parentheses. So I'll get 1/2 times the log of 7 plus, that's going to end up being 3/2. 1/2 times 3, that'll be 3/2 times the log of x. And there's my answer to example 3, 1/2 times the log of 7 plus 3/2 times the log of x. So hopefully this helps. You have 8 practice problems on expanding logs. If you have any questions, please email me. So go do your homework.